Hey kids, welcome to section 4.5, Analyzing Graphs of Polynomial Functions. Today we're going to learn how to graph polynomial functions and locate their zeros, and how to find the relative minima and maxima of polynomial functions. Now the ideas that we're going to learn about today, you've already done in previous sections, but now we're going to have the exponents be greater than 3, which is pretty much what we used previously. So knowing where to expect zeros is essential when graphing a polynomial. Remember, a zero is where the function crosses the x-axis. So there's this idea of something called the location principle that states that if the value of f of x changes signs from one value of x to the next, then there is a zero between those two x values. So look at this picture down here at the bottom. The function that we're graphing is in green. And the location principle says that if one spot, the function value is, say, negative, and at the next x value, the function value is positive, then somewhere in between, the function must have crossed the x-axis or have been zero. So the location principle, a fancy name for somehow if the function's y value is positive and then the function's next y value is negative, somewhere in between it crossed the x-axis and was zero. We also have things called relative minimums and maximums still. Relative maximum is a high point where each value to the right and to the left is below it. And we also have relative minimums where each value to the right and to the left is above it. So let's see how we're going to relate this to our new chapter in polynomials. So our first function, letter A, f of x equals x to the fourth minus 3x cubed minus 2x squared plus x plus 1. The first dot says to graph each function by making a table of values. Well, I've got this table of values here, and I've told you which x values I want you to substitute in. However, it would take forever if we were to sub in all those x values, so let's use the calculator. So go to your y equals, and let's type in our function. So we have x to the fourth minus 3x cubed minus 2x. This takes forever when you're using a pen. Plus x plus 1. All right, so we got our picture here. Let's go ahead and graph it, and let's see what it looks like. So let's, come on, there we go. Beautiful, and then it goes back up again. All right, so let's go to the table. So to get to the table, you hit second, and then you hit graph, and that brings you to the table. And let's try to find in the table these different values that I want. You can use the up and down arrows, kids, to move in the table. So I want to grab -2. So an x value of -2 is 31. Oh, let's move this over a little bit more. An x value of -1 is 2. -1 is 2. 0 is 1. 1 is -2. 2 is -13. 3 is -14. And 4 is 37. All right, so now we're going to graph the ones that we can graph. So that looks like -1, 2, 0, 1, 1, -2, 2, -13. Oh, okay, so the rest of them are pretty much all off the graph. But here's what we're going to need to do. We can't graph -2, 31, but we can put a dot for, hey, don't forget it's going to go up there. And then we can't really graph 2, -13. We can put a dot where we think it's going to be. 3, -14 is going to be a little bit below that. But then look at that 437. I can't graph 37, but I can put a dot up at the top. Now, the reason why I put those dots at the top is because those are my end behaviors. I need to know where my graph is going at the ends. And if I look at my picture, oh, I don't want that. If I look at my graph again, see if it's a little bigger. Take a look at my graph. It's going to go up to the left and it's going to go up to the right. So in my picture, if I connect my dots, I can go like this. And then I'm going to go, ooh, that was a little sketchy there. Sorry, kids. You can go up. So now if we compare the pictures, we can even zoom out a little bit if we want to see if our picture looks a little bit better. So you can hit zoom 3 and then enter. And now it's going to zoom out a little bit so we can see if our picture matches more. Okay, it's still thinking. Okay, all right, so not very good. Remember, you can hit zoom 6 and that'll reset you back to the origin. Oh, no, zoom 6. All right, zoom 6, and that'll reset me. All right, so now we're going to move back to the directions. Determine the consecutive values of x between which each real zero is located. So I need to find the zeros. All right, so if I look in the table, I look at my y values, positive, 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 negative. Ooh, that means that there is a 0 in between here. And then I'm negative, 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 positive. Ooh, that means that there's a 0 in here. So if my 0 is between 1 and negative 2, let's move this over a tiny bit. Oh, sorry. Let's go back to the video that we're making. And we don't need that. Awesome. All right, so, oh, okay, well, what's going on? All right, it's all good. All right, so if there is a 0 right here in between 1 and negative 2, then the 0 is between 0 and 1. Between 0 and 1. And if the 0 is in between negative 14 and 37, that means it's between 3 and 4. Kids also look at the picture between 0 and 1 and 2, 3. Well, that kind of got a little off. We could fix that. Let's see. Let's graph it again. Try to make it a little more accurate. It's kind of hard though. Okay, there we go. All right, now we have to estimate the x-coordinates at which the relative minima and maxima occur. So let's look for the relative minima. Oh, the first one was maxima. Let's try that again. So let's look for the relative maxima, and let's look for the relative minima. All right, to do this, we're going to use our calculators. So let's go back over to our calculator. Oh, can we make it a little bigger? Let's make this, I don't know how it got off. All right, so we're going to use our calculator. Remember, we're going to go to second, calc. And before we do this, maybe we zoom in a little bit. Let's try to zoom in where we think it's going to be, because I saw a dip in the graph, but it might be a little bit hard to place the blinky guy when we're trying to figure out maxes and mins. All right, so now it looks like we're going to be able to find the maxes and mins a little bit easier. So we're going to go to second, calc, and we're going to do the minimum first, so that's number 3. And we're going to move the blinky guy so he's on the left side of where we think the minimum is. And then we're going to hit enter. And it draws that little vertical line. Now we want the right bound, so we want him on the right side of where we think the lowest is. And we're going to hit enter. And that drew a second vertical line. And now I want to hit enter one more time. And it tells me down here that at negative 0.5, x equals negative 0.5, I have a minimum. All right, so let's do the maximum now. So we're going to go to second, calc again. We're going to choose maximum this time. We're going to move the blinky guy so he's on the left side of the maximum, hit enter. We're going to move the blinky guy so he's on the right side of the maximum and hit enter. Hit enter one more time to calculate, and we get a relative maximum of x equals 0.2. Now we have one more to graph. Let's go back to zoom 6 so we can see where it is. Remember, I have one more relative minimum down here in the bottom right hand of my calculator. It's just finishing graphing. All right, so let's find that last relative minimum. So we're going to go to second as soon as it's done graphing. All right, so second calc. Let's find minimum again, which is 3. I'm going to move my blinky guy so he's on the right side of the minimum, somewhere around there. Hit enter. Then I'm going to move him so he's on the right side. He's going to disappear for a little bit. Watch those y values get smaller and then bigger. Hit enter. One more time to hit enter. And it's going to tell me that at 2.6, I have one more minimum. All right, so that's how you can use the location principle to graph a polynomial. Let's do one more. B, we're going to graph and locate. We've got a new function, f of x equals negative 2x cubed plus x squared minus 4x minus 2. So let's go over to our calculator and we'll change out the function. So we have negative 2x to the third plus x squared minus 4x minus 2. And then let's graph it. Remember, if your graph doesn't look right, you can always zoom 6 it to reset it back at the origin. Oh, so this one looks like a really interesting squiggle. All right, so let's go into the table. Notice that I don't give you any x values to use this time. You have to come up with what x values you want to use. Well, if you take a look in the table, it looks like you can get some positives, some negatives, if you just kind of stick around the -2. So maybe we'll start at -2, -1, 0, 1, 2, 3, and 4. And -2 is 26, and 5, -2, -7, -22, -59. Yeah, they keep getting smaller, -130. Graph the ones you can. So -1, 2, 4, 5, 0, -2, 1. That's 4, 6, 7. And then I'm going to do -2 and 26 is like a really tall point off the graph. And then I'm going to do 2, -22 is a really low point off the graph. So when I connect these, it looks like it's going to be a straight line, but it does kind of curve ever so slightly. All right, so if I need to find the consecutive values between which the zeros are located, if I look at my y values, it looks like it changes positive to negative right here, and then it keeps getting negative. So it looks like there's only one 0, and that's going to be between -1 and 0. And then if I look for my relative max and my relative min, well, when I look at this graph, there is no apparent maximum or minimum. We can try to zoom in if we want to. Maybe we can see some kind of curving and switching of directions if we zoom in, but we don't really get a better picture. So therefore, you can have problems that do not have any relative maximums and do not have any relative minimums. And that's going to happen. All right, kids, that's the end of section 4.5. If you have any questions, please let me know. And as always, keep calm and keep trucking.